What if you could run a LLM AI agent directly in your browser? Well, now you kind of can. So using some of the latest technologies, which is WebGPU API directly into Chrome and the Onyx, I think it's Onyx framework. Yeah, you can run an LLM directly inside your browser, no data center needed. Now, as you can imagine, we are downloading the LLM model directly, so it does have to be pretty small, and there's some shortcomings, but we'll go into that here in a second. So I created a very simple example app here where we're going to take a text box. We're going to insert private information here. So this this is a medical patient, right? He's got a date of birth, social security number, medical ID number there, just all kinds of stuff. And the goal is the LLM is going to process this and spit out the same paragraph but with redacted private information. So it allows us to take in, and we can see how accurate the LLM can process this block of text and spit out hopefully the same thing but with the revisions. So before we go into this, the technology to make all this possible is pretty interesting. So for the model, like I said, we have to have something that's pretty small because we need the user to be able to download it onto their computer and run it in their browser. So we need the maximum compatibility with GPUs that folks have. So Liquid AI has some very interesting tiny LLM models with their LFM series. They just released the 2.5 version. And if you know anything about models, even something in the 4-ish to 7-ish billion parameters, that's the amount of processing weights. I don't know what the exact term there is. But the amount of parameters that the model is trained on, something even the 4 to 7 billion range is still considered quite small. Something in the Claude Opus range is in the trillions, and no one knows exactly because it's proprietary, but trillions and trillions of parameters. So the model that we're going to use today, though, is only 350 million, which sounds like a lot, but again, this is a tiny, tiny, tiny model. I think it fits in under 500 or 600 megabytes of RAM. So basically almost any GPU can run it, with the exception, because this is newish, it does have to have a 16-bit support, which basically any modern GPU does, but I was running it into some problems on some older NVIDIA like laptop GPUs where it only supported the full 32-bit version. So very interesting model, super tiny. You can see from the documentation on Liquid AI that it basically outperforms every other model in its class up to 1 billion parameter models here. Yeah, very, very interesting model. I love messing with the Liquid AI models because their performance to size ratio is so good. So one thing to note is as you go down in parameter size, usually your intelligence and your ability to do things definitely goes down as well. Really good models, again, like this one here, have pretty good what's called information density. So they're using that small amount of parameters as much as possible. But it's obviously not going to be as smart as something, with billions of parameters more. So yeah, that's the model. The technology that's going to make this possible is a pretty cutting edge API that is managed by the W3C standard foundation, which they just kind of manage all the web standards. And this is an API built into your browsers such as Chrome. I've had it working on Firefox. I'm sure it works on Safari and things. I just haven't tested it yet. And it allows your browser to access the host GPU directly. So I'm on a Apple Mac with a M4 chip, and my Chrome instance is able to access the GPU on my computer through this API. So that allows us to be able to access it directly without having to download anything, such as in the case of like Ollama, which is a model runner if you're not familiar. And then the last piece that makes this all kind of go together is, like I said, the Onyx framework. I think that I'm pronouncing that right. And what this allows us to do is a lot of these tools that run models, or really any GPU process, there's a big disparity between NVIDIA GPUs and Apple Metal GPUs. An M series chip uses the Metal runtime. And then I think AMD is like ROC or something. So yeah, lots of disparity between all of these different kind of like ways to access GPUs based on the vendor. So this framework allows us to load the model in a certain format that kind of can be used by all those different GPUs. So a little bit of complexity there, but these projects have made this possible basically, where before it probably wasn't. So we go back to our app. We'll go into probably the most important part of this is, again, as I had said earlier, a 350 million parameter model is not very smart. And you'll see that here basically right away. So I've loaded up the base model, downloaded directly from Hugging Face, just as Liquid AI has it set up. We have our test block of sensitive information, and I'll throw another one in just to show that this works with a bunch of different things. And when we hit redact PHI, our prompt again is basically telling the model to copy the entire paragraph but redact any sensitive information. It's a pretty simple prompt, so we're not using up too many tokens in our request, right? And again, this is running completely in the browser. I can even pull up, I guess I can't with my screen recording. I was going to pull up my GPU so you can see that it's working on my GPU, but we do have an indicator down there. But when I click this, you'll see that doesn't look right. What's going on here? Oh, there we go. We got something. But you can see this is definitely not right. We still have sensitive information. Still have the date of birth. It is the correct date of birth. We still have the social. So it's basically not redacting correctly. It's kind of just garbled garbage, and it's very... it's just not working, right? So quite honestly, with a model as small as this is kind of expected behavior. It can't really do even slightly more difficult tasks without too much trouble. Token per second is pretty good though. So what we're going to do to fix this is we're going to fine tune this model. So what this involves, and I'll probably do a second video on this, is there is a really nice data set on Hugging Face that's actually put on by NVIDIA, and it is 100,000 records of mock, just like this, mock text blocks that have sensitive information in it. And then we have our prompt, and then we have the expected outcome, which is the same text block, but we have redacted, all the sensitive information. So exactly what we're looking for. So what I did is I think I took 50K of that 100K, loaded it into a cloud H100 GPU, which is like a $30,000 NVIDIA server GPU. And I was able to fine-tune train this same tiny model on all those records. And effectively what we're doing is we're taking the weights that matter to this task, and we're retraining the weights on this very specific task. So the idea being is that this same exact model, same exact size, same exact number of total parameters is going to be retrained to do our one task very, very well. And if we do it right, this same task that this base model was not able to do should be very consistently able to do the one task that we gave it. But the download is the same size, everything externally, like software-wise, pulling this model in is the same. We just were able to fine-tune train it on this specific task. And quick side note, that $30,000 H100 GPU running this tiny model through 50,000 records, I think it ended up costing like $2 US for the server time that I needed to fine tune it. So obviously buying one of these or even renting a server, month after month is pretty expensive, but this is totally within the realm of anybody being able to do it if you have the tech know-how to kind of get through the training process, which can be a little spicy. So we're going to go ahead and load up the fine-tuned model. We're going to throw that same example text block in. And again, this is the same download size. Again, I think it's somewhere in the 500, 600 megabyte range, which is absolutely minuscule for a AI model. But you'll notice now that when we hit redact, it is going to perfectly redact all the information It's going to perfectly copy the paragraph down, but all the information of this test patient is redacted, and we're getting a very respectable 30 tokens a second. For the nerds out there, this is using KV cache. I did re-encode it after fine-tuning it to use KV cache. For all the non-nerds, that just means that we're getting really good speeds out of it by using caching. So just to show that this can be used in a number of different formats, I have another example over here that I'm going to copy paste. So this example is kind of a order form email, and you'll see that we have, we have like a credit card number, we have a name, again, maybe some things that we don't want to share. So if we're going to redact that, and you'll see the LLM is able to go through and copy the thing perfectly. We redacted all of the address, personal information, redacted the payment method, redacted the name at the end, and yeah, it'll do it pretty much every time. Again, if this was a production use case, I'm sure that you would want to fine tune it exactly for your use case. And this is also something that you could refine tune as you continually grab more and more customer information. But yeah, you can see basically no matter what we get it doesn't get confused, and it's able to redact the personal information and return us the correct text block, not change the actual content of the input that we gave it. So that's pretty cool. Runs pretty well as far as I can test it. This is of course just an example, so I'm never going to make this production ready. So the real question is, why would you do this? So other than it just being kind of cool, to be able to run an LLM directly in your browser, there is some real, kind of sensitive information industry stuff that this could be used for. So as you can imagine, if you were some sort of health tech or medical and you wanted to, again, firewall your employees from sending information out, we can use the LLM to redact all of the information. So, the other way to do this is, and we wouldn't want to do this, is we could send all this data off to OpenAI, ChatGPT, and ChatGPT will definitely do this. Don't get me wrong. ChatGPT is a larger, more powerful model. It'll definitely be able to do this, but we have just given OpenAI a bunch of people's social security numbers that they could theoretically use to train the model on, or, we've exposed data, which is illegal as well as bad. So with this, in this example case, this data has never left our machine, right? So we typed our data in here. The LLM processing has happened completely on our machine and spit out our output completely on our machine, so no information has been leaked, which again, if you work in health tech or legal or any kind of regulated industry, I don't need to explain to you why that's a good thing. So this is, of course, again, just an example. Your mileage may vary depending on what you put in it, but it just is a proof of concept that we don't need to, one, be leaking personal or sensitive information to these big corporations, and two, it's totally possible to run a useful AI workload without a data center GPU. I'll be providing the links to the code base, to the model weights, and the data set. So everything is open source. You can take this model, you can even take the fine-tuned one and you can run with it. I don't care. Put it in your own application. But yeah, definitely test it out and let me know what you think. We'll probably be doing another video on how exactly to fine-tune this, like the actual kind of setup. But yeah, we'll see ya. Thanks for watching.